Yes. So, good morning, Professor Zolman, and good evening, everyone. It's a great pleasure to welcome you all to this fourth lecture series of Physics Education Research, Season 2, organized by IAPT RC23 Himachal Pradesh. On behalf of organizing committee, I extend a very warm welcome to all our distinguished guests, respected teachers, researchers, scholars, students, and members of IAPT family who have joined us this evening. So today we have a distinct privilege of hosting one of the pioneers of physics education research and an internationally renowned physics education researcher, Professor Dean Zollman from Kansas State University, USA. So, as artificial intelligence has rapidly become part of classrooms and everyday learning, today's topic of his talk, Artificial Intelligence and Physics Education Research, is particularly very timely and relevant. So, thank you, Professor, for joining us. And now I would like to invite Dr. Kuldeep Sharma, President of IAPT RC23 Himachal Pradesh and Professor of Physics at NIT Hamirpur, to formally welcome our guests. Over to you, Dr. Kuldeep.
Thank you, ma'am. Uh, Good evening and morning to all of you. Uh, on behalf of RC23, I take this opportunity to extend my heartfelt welcome to each and everyone present here in this lecture series, especially uh, today. Uh, Today's speaker, uh, Professor Dean Jolman, Kansas State University. Uh, I would like to just uh, uh, talk about his previous contribution in this lecture series also. We are very happy to see you again in this lecture series, sir. And on 28th July 2025, he delivered a talk in the webinar we conducted on teaching quantum mechanics and PER studies. Topic was using interactive visualization to engage students in learning quantum mechanics. He is a distinguished professor emeritus, and we are honored to have today again with us you, sir. So, Professor Dean Jolman will deliver a very uh, uh, good talk today on good topic AI tutoring and physics education research, which is very relevant for today's, as far as today's education is concerned. Uh, I take this opportunity to welcome you, sir, to this uh, lecture on this PER lecture series. And I will also extend my heartfelt welcome to our President IAPT, Professor P.K. Alwalia ji, uh, Professor Rekha Gorpade, Madam, uh, Professor Bandana Luthra, and all senior IAPT members, and my colleague Dr. Sapna for organizing such a wonderful talks. And uh, I hope we all will enjoy and get benefited from the talk of Professor Joel Mann. Thank you, sir. I once again welcome you all to this session. Over to you, ma'am, Sapna. Thank you, sir.
Okay.
Thank you, sir. Thank you. I think there is a problem here actually. Uh, so yeah, electricity. Sorry, there is a electricity problem, but I will continue and one minute. So can you hear me? Actually, can you hear me, sir?
Yes. Are you waiting for me?
Yeah.
Okay, let's get started then.
No, I will just like to invite Professor Vandana Luthra, the chairperson of today's session. But before she takes over, I would like to briefly introduce her and share a few words about her distinguished academic and professional journey. Professor Vandana Luthra is officiating principal of Gargi College, University of Delhi. She has been serving as a professor of physics at Gargi College since July 2018. She is a distinguished academician, researcher, teacher, and a passionate practitioner of innovative and active learning approaches in physics, and has been the recipient of prestigious international fellowships, including the Boyce Fellowship of the Department of Science and Technology, through which she worked on gas sensing materials at University College London, UK, and the Raman Fellowship of the UGC at the State University of New York. She has also been a visiting researcher at UCL UK. Under her leadership, a physics research laboratory at Gargi College has been established, providing facilities for the synthesis and characterization of functional materials and supporting research projects of both undergraduate and PhD students. Her accomplished have been recognized through several prestigious awards, including the Meritorious Teacher Award by the Government of
वहां
Delhi,
पर एक दफे 4-5 दिन बाद फोन करना, तुझे नहीं
the
मिलता है।
IIPT Dinabandhu Sahu Memorial Award, and the Teaching Excellence Award for the Innovation by the University of Delhi. She has also been recognized for her contributions to digital literacy and innovative educational practices. She has more than 38 research papers in international journals, book chapters, e-lessons, and numerous invited talks and academic presentations. So, and there is also a creative side to Professor Luthra that beautifully complements her scientific persona. She has penned poems on themes such as hope, light, and beauty of nature. A reminder that science and creativity can beautifully coexist. Ma'am, we are delighted to have you with us today. And now I request you to kindly take over the proceeding of today's session. Over to you, ma'am Vandana.
Thank you so much, and my warm regards to everyone here. Thank you for your kind introduction. Greetings to Professor Aluwalia ji, Professor Ghatak, Professor Rekha Gorpade, Dr. Kuldeep, Miss Sapna, Dr. Sapna, and all the dignitaries who are present here today in this meeting. It's our delight to give warm welcome to Professor Dean Zollman from Kansas State University. Sir, we welcome you here. And it's our privilege to have you and listen from you on a very, very, very important topic, which is (2026), which is session 2, that again shows the dedication of the team in terms of completing so many lectures and still continuing with another series of lectures in session 2. And I congratulate each and everyone associated with it, Professor Aluwalia, Dr. Kuldeep, Dr. Sapna, and all the team members of RC23. Professor Dean Zollman from Kansas State University, I would be very happy to read his biography for the benefit of all the participants to show that how dynamically he has been working in this area for last many decades, and I would like to read that for everyone. Dr. Zollman earned his PhD in theoretical nuclear physics from University of Maryland, College Park in 1970, and his MS in 1965 and BS in 1964 from Indiana University, Bloomington. Dr. Dean Zollman is a university distinguished professor as well as a university teaching scholar. Since 2001, he was head of Department of Physics and Williams and Zone Porter Professor at Kansas State University for 10 years. In 2006, he was named KSU's Outstanding Department Head. He has focused his scholarly activities on research and development in physics education since 1972, and he has received 3 major awards, namely the National Science Foundation Directors Award for Distinguished Teachers Scholar in 2004, the Carnegie Foundation for the Advancement of Teaching Doctoral University Professor of the Year 1996, and American Association of Physics Teacher in the year 1995. His present research concentrates on investigating the mental models and operations that students develop as they learn physics and how students transfer knowledge in learning processes. He has also applied his cutting edge technology to the teaching physics and to providing instructional and pedagogical material to physics teachers, particularly those teachers whose background does not include a significant amount of physics, that is, to non physics teachers and students also. He has been a Fulbright Fellow in Germany twice. In 1989, he worked at Ludwig Maximilian University in Munich on development of measurement techniques for digital videos. In 1998, he visited again and the University of Kiel, where he investigated student understanding of quantum physics. And during 2006 and 7, he also returned to Germany and spent one semester at each of the universities of Ludwig Maximilian University in Munich as well as in Kiel, where he conducted research on teaching of medical applications of physics and on teaching of quantum physics. He has been a co-author of 6 video discs of physics teaching, and which also shows his widespread interest and its association with different groups of students, which are non-science, science, and engineering students, and students interested in other subjects such as biology and medicine. So today he will be talking about highlighting the significance of AI tools and ensuring students utilize these tools with critical thinking when they are utilizing for physics educations and its role in physics education research. He will be going through different learning modes with the current AI tools and comparing them to prompt engineering methods, and with a comparative study, he would also highlight its role for the physics education research. So, sir, we welcome you here and we are looking forward to this enlightening talk, which is going to be beneficial for not only for teachers, but also for the students. Welcome to you, sir, here.
Thank you.
Over to you, sir. Yeah, thank you very much.
Okay. Let me start by sharing my screen. And okay. First check is, can everybody see my title screen and hear me?
Yes.
Okay. Then we're starting well. Okay, I frequently start talks with a few pictures so many of you may have seen these before. They're pictures of teaching from somewhat long ago, 17th century. You can see the lecturing here or tutoring is not going very well because most of the students don't seem to be very engaged. About the same time, Rembrandt made a painting where the students are particularly engaged, and they're engaged in part because there's something more to look at than just the teacher. More recently, we get pictures like this, particularly in the United States, where many students are in a lecture hall and they're not necessarily learning very well, but a view during the 19th century, end of 19th century, of what it would look like in the year 2000 is this, where the professor is feeding books into a machine, a student's turning a crank, and it's being fed into all of the students. Unfortunately, that doesn't quite work as we would like it to, but with today's artificial intelligence, we're getting close to some connection of technology with the individual students. And today in particular, what I'd like to talk about is how AI has become important in individual tutoring of students. And just to make sure we're all on the same page, I'm going to define individual tutoring in the way that it's shown on the screen, that it's outside the formal class, one-on-one with a student and an expert, most typically in something that we call a Socratic dialogue. In physics, generally, these tutoring sessions would address a specific concept, build on the student's prior knowledge with the goal of improving both content and the student's reasoning abilities. Okay, now, if we look back at PER over the last 50 years, we can get a pretty good idea of what ought to be involved when we're doing tutoring. First, of course, the students must be actively engaged, as I showed in the first slides. We have well-documented information on what students bring to their understanding by what's been frequently called misconception research. I prefer to call it prior conceptions. What we know is that the way we want to build student knowledge is incrementally, that is, transfer information from the general field to the students in small steps so that they can do what they can from there. And we need to start with what the students already know, even if that happens to be what we commonly call a misconception. And certainly over the years, what we found is that we can't focus on algebraic skills because students will learn to be able to do the algebra of physics well without necessarily really understanding the concepts behind them. So all of that is built into what we should be doing when we're trying to help students in a tutoring situation. So the question now is, can we apply these ideas using generative artificial intelligence and help the students learn in these tutoring sessions? So we need to create situations where students use the AI to clarify their understanding, but not just help them with homework. That's certainly happening a lot, and I've seen it here, and it's not really helping with homework. It's getting the AI to do the homework for the students. So that doesn't work very well because it doesn't provide the students with a good way to look at the concept, to interact with the AI agent, diagnose their difficulty in learning, and then suggest ways in which they might learn it better. So there are a couple of issues that we have to face here. One is that generative AI has not done terribly well in conceptual level physics. And I've quoted here a result from a paper that was done just a few years ago. Excuse me. Actually, yeah, and found that the force concept inventory gave ChatGPT 4 some significant problems. However, that is changing rapidly. And this past summer, Grigorek gave a paper on how AI has gotten better at physics reasoning. And the timeline is shown here that prior to 2022, most AI type interactions were pretty bad. They really missed the qualitative issues while solving numerical problems, very much like our students were. But with the advent of ChatGPT, that has been changing. Just a sec. And in the last 3 years or so, the AI models have so maybe they made it up, but it's about right. So let's look at the second issue, which is what I've mentioned already, that in the normal mode that AI agents work, they provide answers. They mostly don't interact as a dialogue with the student involved. They just put out answers and let them deal with them. This has led to a couple of new phrases, at least new to my vocabulary, that students, from what the students do, they accept the answers, think they have learned, and moved on. This has been called cognitive surrender. The student surrenders his or her cognition to the AI. And the one I've seen most recently that I kind of like, thoughtless use of generative AI, which has been abbreviated DUCA, and that appeared first in this paper at the bottom, which is a study from a group of Chinese educational psychologists on this particular topic and did look at gender differences as well as other things in this thoughtless use of generative AI. And just, I'm not going to dwell on this, but these folks found that the effect on student reasoning is, and the negative effect is greater among male undergraduates than female undergraduates. Now, the study was done in China, I think 4 universities, as I remember. So there may be some cultural differences elsewhere, but the way they laid this out, it sounded very much like our students too. However, there is a change that how students interact with the AI can make a great difference. And I've created or brought in a couple of quotes from another Chinese study, even bigger than 4 universities, in which they looked at how students used AI and how that influenced their cognitive and creative reasoning. And both quotes here are kind of the same idea, that if we frame the pedagogy for the AI effectively, the students can, in fact, improve their learning, improve their cognition, and improve their reasoning while they're using AI. Now, excuse me, this has led, not this particular paper, but the general idea has led the AI models to start looking at ways to use AI differently from their standard ask a question, get an answer mode. And the 3 of the major AIs have in the last year or so come up with various things that they use and have students take a look at so that they're interacting with the AI rather than just getting answers. And each of them have called it something slightly different, but it is the same idea, basically, that is involved in each of them. In addition, you can build your own. Gemini has something called gems that let you tell the AI how you want it to answer future questions. Answer is not quite the right word, how you want it to interact with you on the future questions. And then I'll talk some more about prompt engineering a little bit later. A rather nice website that goes through this, I've listed at the bottom, where Daniel Nest actually conducts a series of interactions with each of these three to see how they respond. And it was actually done last year, and it's a little out of date in that the user interfaces that he describes have been changed somewhat, but the basic idea is still a good one. Okay, so what I'm going to do from here on out is show examples. I have to preface this with the, I'm sorry about this, with the statement that I have not tried any of these with students. As was mentioned earlier, I'm an emeritus professor, so I don't teach right now, and I actually give these to my colleagues and see how things go. But right now, these are things I've done over the summer interacting with the AI and to see how all of this works. So my first one is a straight prompt, not using the study or learning mode, just having AI tell me something. And I tried to phrase this in the way of a student who's listened to a physics teacher and feels that his physics teacher is wrong. And would like the AI to help him convince his physics teacher is wrong. So it's basically the common misconception about which has a greater force on it when a car hits a truck, and what Newton's third law says. Now, fortunately, all three of these models started out with the same thing, that actually my teacher was correct, that I didn't understand something. But then it just provided a few paragraphs of text providing Newton's third law. Basically nothing different than what I would have gotten had I just gone to Wikipedia and searched for Newton's third law. So it was not interactive, and it just said, here's what it is, students, your teacher's right. There was one exception, which was Claude in this case, and I really liked the way they finished that, and that is it gave me a suggestion on how I should interact with my physics teacher. And indicated that we should have a follow-up conversation rather than an argument, try to win. So I thought that was rather nice in terms of providing the student at least with something to go on if he or she would like to take this further with the teacher. But still, there was very little interaction about helping the student understand what was going on with Newton's third law. So now I tried to use the study or learning mode to do the same thing with each of these three learning or artificial intelligence models. And I'll just go through each one to tell you what happened in these cases. First, with ChatGPT, it started by asking what level I was studying, high school or university. When I told it, it then said, let's build from what you probably already know about forces. Well, it never asked me what I already knew. It assumed what I already knew and went from there. Then there were a series of 8 questions. Each question I had to answer, in each case, I tried to answer it as a student would without getting too far out in terms of bad conceptions or so forth. And so we went through these 8 questions, and then we get to the point where ChatGPT says it thinks, I think you've got this figured out. Can you please, sorry, I'm too early in the morning, I guess. Uh, can you put Newton's third law into your own words by using the truck and car example? And then it asks the final question, which of course is one that is a common conception among students of why do these two equal forces, one on the car and one on the truck, not cancel each other out? So I answered that as well, and ChatGPT and I went away being friends and having a fairly good feeling on how the whole thing works. With Gemini, I was not quite as satisfied with it. It started with a statement of Newton's third law, did have 8 pretty good questions about the car, the car and the truck and Newton's third law, but it had no summary questions. It didn't ask me to summarize what I had learned. And so it was only a short statement of the summary at the bottom. And then with Claude, Claude asked about level and background. So it did try to get some information from that. And as far as I could tell, it used that information to build a series of questions. And then once we had worked through the car and the truck, it went on to talk about the acceleration of a rocket and the gas in the rocket as a summary of what I had learned. Then after that, it asked me this rather interesting question. It said, do you want to try one more scenario to stress test it being your understanding? I declined to go ahead and do that at this point because I'd spent a lot of time doing all of this, and it didn't seem like it was going to be very valuable for me to learn more about Claude. So in any case, in a quick summary, it seems that the most important thing in this study or learning mode is that the AI model immediately moves from giving me information to providing a Socratic dialogue about how the Newton's third law works. So it builds a understanding rather than just giving me an answer. So that's a good step. Now, another approach is what is called prompt engineering. And prompt engineering has a rather simple idea behind it, in my mind at least, and that is if we submit a good query to the AI, we usually get a good response. One of the most important things, and I'll emphasize this again later, to the AI is to assign it a role. And this is now sometimes called role engineering, that we give students, or I'm sorry, we give the AI a specific role to play. And in the case we're going to look at in a minute, that role will be to be a good tutor. And now the question is, can we actually help students submit queries which lead to good learning experiences? So first, the components of a good prompt is first, of course, you have to establish a task. Then any background that might be important. And in my case, it's always, I'm a student learning physics. And then from what I have done, I think the role of the AI is the most important part of the whole thing. What are you asking the AI to act like? Or who are you asking it to act like? And then finally, some expectations of what the output should be and for what audience it should be. Okay, so with all of that, I built an engineered prompt and I've only done this with ChatGPT. And I start with, you are an expert physics tutor. Use good tutoring techniques by asking questions instead of answers. Apply the research, basically the research of PER. And then I say, I need help understanding Newton's third law. So most of what I'm doing here is providing a role and an expectation of what I want AI to do. And I get what I consider a rather good response. In fact, I think I got a better response this way than I did when I put ChatGPT into its study mode. So the beginning was, we're going to do this as a Socratic physics tutoring session. We'll focus especially on the common misunderstanding students have about Newton's third law. So in many respects, that's exactly what we would like a human tutor to do. Then I had 15 questions. What it didn't do is it did not ask about my level of study or my previous knowledge. It jumped directly into, you're standing on a floor and you're applying a force to the floor. What are the other forces? And then we went from there and we did quite a bit of interaction with that, and then the car and the truck example and so forth. And then a summary at the end was about force pairs. Again, why does one force not cancel the other force since they're equal and opposite, and of course are on different objects? And then finally it told me that I'd done a good job, which is always nice to hear, and I hope it was true. Now, with that, let me provide, and I'm getting close to the end here. I know we're trying to end in about an hour. So let me give you some tentative conclusions. And I make these tentative because I've done it and I haven't actually involved students, although I've involved the AI quite a bit. Okay, in the learning and study mode of the three AIs that I used, they were rather equivalent. They were rather equivalent in the type of Socratic dialogues that they provided and in their focus on what the force pairs were. So they used what is one of the most common difficulties that students have, that the forces are on different objects.
Okay.
And that therefore they don't cancel each other out, as well as the dialogue in getting things done. I preferred the ChatGPT and Claude approach because they ask at least something about the level that I was studying at the beginning, and they ask for a summary of some kind at the end. And the prompt engineer that I built for myself, I thought worked better for those two factors than either of the others. And then The prompted chat seems to be more thorough than the study modes, and particularly more focus on preconceptions as identified by physics education research. Okay, so this is sort of a research into what AI does rather than what students do, but all of the variations did show a good application of PER. They showed some interactive engagement. They were working toward conceptual change, and there were step-by-step scaffolding rather than making big jumps. Informative feedback with some on-the-demand clarification as I asked for it. However, this has some limitations as well, this study of AI. First, I didn't end up doing exactly the same thing with each AI. In a perfect study, my research would be that I would make sure that all the questions were the same, but the AIs were not the same. So my input responded to them rather than giving identical results each time. Now, I did learn that the previous interactions I had with each AI may have been remembered by them, even though I was starting a new session. And the best example of that is this that came from ChatGPT. You'll remember that when I gave it just a statement to get an answer without prompting it to do interactions, I used the car and the truck and the damage that would be caused as an example in my prompt. Well, I did not mention that when I went into the study mode. But near the end of what we were doing, ChatGPT said, earlier you were bothered by the fact that a car can suffer more damage than a truck, blah, blah, blah. Well, that was from 2 days earlier. So ChatGPT was not letting me off the hook and letting me pretend that I was doing this from ground zero. So I may have influenced them by what I had actually done in the past rather than what I was doing now. And then, of course, I did this over a period of actually a couple of weeks. And in fact, I did a little bit of some of it before I went on a 2-week vacation and some after I came back. So no doubt AI training was occurring during that time, and the AI was building more information about itself. So all of these could affect what I had seen, although I think some of my general conclusions are still good. Let me now just conclude with a couple of ideas that came out. In a separate interaction with ChatGPT, I just basically asked it how I could use their AI in study mode to teach in a class. And here's what they recommended, although I've modified this quite a bit. They have students work in pairs, which is a good idea. All work on the same topic, but with each group creating its own prompt. And then in the end, the group share and discuss how the wording influences AI's response. So they're reflecting on their interaction with AI in addition to trying to learn some ideas in physics. Now, all of this leads to some issues. First, AI is changing incredibly rapidly. And as I said, probably even during the time that I did this little research on how AI works. So creating materials that are just for existing AI bots is useful, but we're not going to keep up. We're not going to be able to do the development as fast as we can. We need to help students learn how to develop their own prompts and to use the study and learning modes effectively. We need them to reflect on their own learning with the AI as well as in the classroom. And then the question is, can we build a set of general principles for creating prompts that apply to teaching and learning that we can teach our students? And then, of course, what types of activities can we use to supplement what we're doing now that go far beyond having the students look up the homework answers with AI? And then can we increase interactive learning with prompt engineering? I think the answer to that one is definitely yes, but the rest of them we're still working on. So the biggest issue, of course, is how do we get students to use the study learning mode or well-designed prompts rather than just looking for answers? And that I don't have an answer to at this point. It's going to be difficult, but hopefully we can give students information about how they're learning and how they can use this to learn instead of just get answers. So with that, I'll try wrap things up and say this is incomplete. We are still working on some knowledge and how we can make this work. And the folks listed here have been instrumental in helping me clarify what I have been doing and how I'm trying to make it work. So thank you for your attention. And of course, willing to answer questions. We've got a few minutes left. Let me, while we're thinking about questions, put up a slide that has the references that I listed during the talk on them, so you can take a look at those. So,
Yeah,
any questions?
Yeah, thank you so much, Professor Zolman. It was such an enlightening talk, emphasizing on the role of AI in the current times. Our classrooms, we can't be now devoid of AI, so we have to adapt and adopt to the changing times. And the way these are evolving would mean that there has to be strategies in order to see, and you talked about the challenges, you talked about the issues and the differential roles of different models, because each model is using at the back end a different network, different model is being used, and so there may be variation from model to model when we are going to talk about different tools. And in this regard, it is a topic of research and study, and your talk will always be useful in basically coming out with more and more rigorous discussion on these. And I would say thank you so much for the talk, and the house is now open for questions. One can raise the or can write in the query or can unmute and ask. Thank you so much. Yeah.
Hello, sir. Good evening, everyone. Good morning, sir. I'm Ajay Mokta, and thank you so much for such a great session. Uh, uh, Session was quite good, but I want to just give some framework, what I learned from this session. Basically, before we asking blindly to any question to the AI, because these models are simply a next word predictor model. Okay, they do not have such idea how to reason thing. For now, if you go for the paid models, it might be quite good, but the thing is ki, as Professor Dean Zolman suggests us, we always need to uh, cross question the AI models. So I think these are some simple framework that sir want to told us. Like, first we need to diagnose thing. What do I already know? Okay, and second question, make me think. Not just AI give me some answer and I got satisfied with that answer. So we always try to put some questions and so that uh, it get me to it like my mind get in that zone so that I can wonder for some solution. Okay, and third one is challenge. Okay, like how can I find my misconception? And I think and fourth one is scaffold, like give me these next step, not the answers, so that I can put my brain into that process. And finally we have to reflect, ask me to explain what I learned basically. So we have to make some layering so that we can put our brain in use, not use these AI models blindly. So this is, I think this is what I learned from this session. And thank you so much, sir, for such a great session.
Okay.
And I
Okay.
don't have some questions, but it was a great session. Thank you so much.
Thank you so much. Yeah. Professor Aluwalia ji wants to ask. Sir, please do ask.
So thank you very much, Professor Zorman. It was a wonderful session, and I was trying to look at it from the point of view of the teacher before he has to go in the classroom to teach some topic, because teachers also have what you can call as other kinds of conceptions. What do you think we can positively make use of AI for enhancing our teaching experience and making it more effective for learners?
Okay. I mean, think in my present thinking about AI, I think there are two areas that can help. One is that we can, in our teaching, ask AI what we can do. How can we address the students given whatever constraints we have? If we have a large class, if we have a limited number of, say, demonstrations and so forth, and the AI can come up with some ideas. And I have to admit, I did that in preparing this talk. I asked all three of the ones that I'm working with here what to do. I said, I'm giving this talk, blah, 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 blah. Even included the fact that I was giving it to teachers from India and asked them what they could do. They gave me some good ideas and they gave me some terrible ideas. And so I filtered all of that. If you remember, I have two slides in here that actually were generated by the AI bots. They generated a whole bunch for me. And in fact, the only one that really surprised me was that Claude came up with what I thought was a better title for the talk than I had, but I'd already submitted the abstract, so it's too late. But I think we can use that, but we have to really filter it. And because we know our situation and they do not, but they can help us improve our teaching in that way. The other side of it, I think they can do a lot to help improve the students' learning as a supplement to our teaching. And that's what mostly I talked about here is if we get students to start using AI in a method that they can learn from, they can learn some more. And how we get that interaction going is the hard part. I think what I would like to do is I can tell the student, well, we're having trouble with this concept. Go talk to ChatGPT for a while and then come back and talk to me some more after that. But don't just learn from ChatGPT, learn from my interacting with you and my interacting with ChatGPT. So I don't know, does that answer your question? Those are the ideas that I'm thinking about at this point.
Thank you. There was another thing which was coming to my mind. Most often it happens that students, when a human teacher is teaching, they don't tend to ask questions. That's why they don't ask questions. Second can be that they don't want that sometimes there is this kind of a situation also where they think that maybe my question may be wrong, I should not ask this and all these things. Do you think that these kind of inhibitions can be taken care of by AI and make them better, inquisitive students than when they are interacting with human beings?
Yeah, I think so. One issue that I haven't really thought about, other than to think that it's an issue, is how can we use AI during a class? I don't know, does that get to your point somewhat? Yeah, that I have over the years used a lot of different lecture response systems, but they're mostly multiple choice stuff. There's not, it helps me understand if the students are following me, but they doesn't go deeper. Can we go to AI and do that? I've read one paper where uh, a, a group of teachers tried to get AI into a lab environment where uh, the, and I'm not remembering exactly how it works, but it worked in the sense of students are doing an experiment. They ask questions to the AI about the experiment and what they should do and so forth, and keep going that way. And like all people who do these sorts of things, they were convinced that it worked well, but that's about it. It's not um, anything particularly profound at this point. And I do hope that we can figure out how to use AI so the students are interacting with us as professors and with students at the same time, and with the AI. I'm not quite sure we're there. Well, we're not there, but and I'm not even quite sure how to do it.
Well, thank you very much. Thanks.
Okay.
It was really
Let's see. Sorry, go ahead.
It was a wonderful session, I said. I think,
Yeah.
and that's
Okay.
great.
So
And
I've got a couple
particularly,
questions.
your lecture has a very important relevance for us in India these days,
Yeah.
because we are passing through a phase of what you call as National Education Policy 2020, where we are actually saying that we should have better learning possibilities in the classroom. And maybe if that can happen, if that happens, I think that will be good. And maybe I would like to be an optimistic person and will say that yes, it is going to do good both to the
Yeah.
teachers as well as students.
Okay. Let me deal with a couple of questions that's been in the chat for a while. One is basically, do I think that
can I ask you, Professor, can I ask you a question? A query is coming into my mind. Suppose we are using AI assisted, say, learning in the classroom. So can you suggest some research methodology which can be used to evaluate it? If we are using some this thing, AI assisted learning in the classroom.
Yeah. Uh, well, the real question in my mind is, are the students learning both the physics concept and to do reasoning better? And I think a great deal of the issue is that students are turning the reasoning over to AI and they're not doing it themselves. So to evaluate how well it's working, we have to do something to evaluate that reasoning. And some of that can come from some of the concept inventories, but I think some of it has to come from interviewing students, giving them an issue and letting them reason about that issue and see how they do after they've interacted with the AI. Does that help?
Yeah. Thank you. Yeah. Yes.
But I think focusing on assessing the students' reasoning abilities is an important part.
Important thing. Yes.
Okay.
Thank you.
Okay. Now I had a hand raised, which I think is no longer raised. I'm not sure.
Okay, sir. Can I ask one last question from you?
Ajay, ask it later. Then Gurleen, please ask your question.
Okay, so
Hello, can I come in for a minute?
Yes.
please?
Yes, yes.
Yeah. Hello, yeah. Good evening. Good morning for you, Professor Zolman. Good evening for us here. So
yeah,
my question was, that my experience with prospective teachers and students, tells me that they're not able to put their thinking process into words. They have difficulties in articulating their own reasoning process. So, given this situation, do you think it is a little there is a danger of AI being falsely trained or mistrained, since teachers themselves suffer from a range of misconceptions or alternative conceptions, whatever, or intuitive notions? How then do we take care of this?
oh, yeah. That's of course the biggest question in probably in all of physics education, isn't it? That we have to get students to reflect more on their own learning. I think maybe we can use AI to help us do that so that students start thinking more about their own reasoning and what they are learning and how they are learning it. But I really don't have an answer to that question at this point. It's a very good one. And I would I would like to think that we can develop ideas that can mostly help students reflect on what they know and how they reason, and then use that to help them improve. I mean, it's always what we can do is to help them improve and not somehow improve them ourselves. So I'm not answering your question because I really don't know the answer to that question. I'm sorry. Yeah. But I hope that helps some. Yeah.
Yeah. Thank you so much. Yeah. I think it's a battle we need to fight together. Thank you so much. Pleasure, sir, listening to you. Thank you.
Okay.
Now I've got at least one hand up and still have two questions in the chat to deal with. Let me deal with the chat for a minute. And one of the questions there is there a danger of false learning by AI, given that even teachers are sometimes not able to put their learning process into words? And that's absolutely true. And I think there's always the problem that you can get into one of these tutoring modes, whether you have prompted or whether it's just the mode of the chat bot, and it goes off in the wrong direction and it takes the students with it. And we all have problems with that from time to time. And I'm not sure how we counteract that very well right now. One possibility is, as ChatGPT suggested to me, is have students work in groups and then have the groups compare their answers each one so that they can then find some false learning and deal with that. And at the same time, put their learning process and their thinking into a more tangible form, I guess, is more concrete form, so that they can learn more about then the whole process of their learning. Okay. Now, the other one that I thought was a question on the chat was really just more of a statement. So let's see, I have one hand up under a label of 1+.
Yeah.
So can you go ahead?
Good evening, professors, and good morning to you, Dr. Dean. I hope I am audible.
Yes, you're audible.
Yes.
Okay, so I'm a student here, and I wanted to ask some question like related to AI learning. So, like when we students usually learn through AI, we usually like to learn it through first principles. We try to create an active learning environment with it. So, like I personally mostly use AI in voice mode. So like if I'm stuck in a concept, like I like to talk to it, even though I know it's just a robot behind. So just like whenever we are like understanding something, the AI does not necessarily correct me always. Like if I'm going in some wrong direction, it does not always point that out. And after I read a book or text somewhere, then I only find out, okay, I had this wrong understanding, and I had this because AI did not actually pointed that out specifically that part. So, like, how do you deal with something like that? Like, can you always trust the text AI gives you, even if it is a very good next word predictor? But can you always trust the text or the like, as the previous question said, that it gives you false learning? But even not false learning, when you have some wrong understanding of some concept, but it does not point that out. Like, how do you fully trust that, or how do you like solve that problem somehow?
Yeah,
Thank you,
I think one issue is that it's always good to use more than one AI model so that you see how things are going. I did read one paper where the authors suggested that you tell the AI that it should not be nice to you.
Oh,
That
yes.
one of the problems with AI is that it's been built to respond to you and to kind of tell you that you're doing a good job no matter what you're doing. And I tried to get at that a little bit with my original prompt about Newton's third law and the car and the truck, but it didn't tell me that I did a good job. But that was a fairly straightforward question and not the sort of thing that might be a little more complex. And so that it's probably good just to double check everything. And as you say, the reason you have found that maybe you were reasoning incorrectly was because the books that you looked at or the people you talked to pointed out that the AI or pointed out that your learning hadn't worked quite the way you would like it to. And in the end, that's the best you can do, is really just reflect on everything and try to double check everything. Yeah. That's probably things you've heard before. I don't have any magic answer to that. So,
Yes, Ajay, you can ask the question.
Okay, thank you, sir. Professor Zolman, while going through one of Google's recent blogs on AI and mathematical discovery, I came across something that really made me stop and think. They describe an AI system that, rather than simply being asked to solve a mathematical problem, actually discovered a more efficient way to doing mathematics itself. For example, finding new strategy for matrix multiplication and reducing number of computational steps. That made me wonder if AI increasingly starts discovering mathematical methods, providing result and finding solutions that we are not explicitly given to it by humans. What happens to the role of mathematician or physicists? Could there be a future where our role shifts from doing the mathematics to deciding which questions are worth asking, understanding what an AI has discovered, and judging whether that discovery is physically or mathematically meaningful? And from an education perspective, how should we prepare students for that future without making them feel that the skill are they are learning today will become irrelevant?
yeah, that's a difficult question also. Folks have been asking really hard ones. Uh, yeah, I think a lot of it has to do with teaching students to be able to reflect on what they're learning and how they're learning it and what the limitations of the system really are. And I think that probably what we need to do with students is come up with some ways to get the AI to give us not as good answers as we would like, and then be able to talk about why there might be a better way to think about things or a better reasoning path to follow than just the pure ones that we have going. I'm not sure I've answered your question very well.
Yes, sir. I think it is a challenge for us because as a human, we proud on ourselves that we are intellectually smart. Because we never proud on our physical power because we know the cheetah can run faster than us. But we proud on ourselves because we can find some solution, we can solve some problem. But if some AI or some robot can solve it better than us, then we can like why we what we are doing and what is our existence, then these questions will be arise. And now we feel because more humanly because of our intellectual. So I think these are some challenging questions that humanity going to face in future. So I think we need to prepare coming generation and ourselves for those questions as well.
Yes.
Okay.
Okay, thank you, sir.
Yeah.
So I think thank you so much for answering all the questions with so much patience and addressing to each and every query. I would like to say that for the students, it should be the way out that filter out the knowledge which is getting and try to see the proof of that and try to see that those things, the AI is being used in a critical role as a critique rather than just always doing saying that it has done a nice job. And for teachers, it would be to supplement with the engaging activities other than the AI, so that it also gives the reflection on what all has been suggested by AI. And also rigorous research is also required in this area, because as the models are evolving, the ways and the methods and the research also need to evolve in this direction. So thank you so much for your enlightening talk, which is also crucial in today's time all the more. And thank you so much, RC23. I take over, I give back to Dr. Sharma for the further proceedings. Thank you so much. Thanks for the opportunity.
You're welcome.
Yeah. Thank you, Dr. Vandana. So thank you, Professor Zolman. It was such an interesting talk, actually, and I think we had a lot of discussion also. So with this, we come to the end of this session. But before ending, on behalf of IAPT RC23 Himachal Pradesh, I extend our heartfelt gratitude to our distinguished speaker, Professor Dean Zolman, for delivering such a insightful and thought-provoking lecture. So your discussion on the role of artificial intelligence in education has given us much to reflect upon, and inspired all of us to think more deeply about the future of teaching and learning in the AI era. So I have sincere gratitude goes to Professor P.K. Aluwalia, National President of IAPT. I also extend my heartfelt thanks to Professor Vandana Luthra for chairing this session so nicely and efficiently. I'm thankful to all the senior professors, all the participants who have joined us today. So, as we continue our journey through Physics Education Research Lecture Series, Season 2, we hope these interactions will inspire innovative teaching practices and encourage meaningful research in physics education research. So, thank you all once again, and I hope we look forward to welcoming you to the next lecture of this series, which will be coming next month. Thank you very much. Professor Zolman, have a nice day, nice Sunday, and good night, everybody from India. Thank you so much.
Thank you so much. Thanks a
Thank
lot.
you so
Thank
much,
you,
ma'am.
everyone.
Thank you.
Thank you,
Thank you,
Professor
everyone.
Zolman. A pleasure to be here. Thank you.
Thank you.
Thank you.
Thanks.
Thank you very
Thank
much,
you,
Mr.
Doctor.
Chopra.
Yeah,
It's
thank you.
always a
Thank you.
pleasure to listen to you.
Yes.
And